Now we talk about the sampling and data holder. If you remember, if your signal is analog, want to go to digital, we use the sample, and if you have in the digital you go to analog, you use the hold. We see the transfer function about both of them, sampling and hold. How we can model and analyze the effect of the sample and the hold block diagram. This is the show the here changing the analog to digital and the digital to analog by hold. First, impulse sampling. Let E be continuous time signal. If we observe E at the instant time of the Tk, k belong to n, we get the sequence of the Es or the E sample k, defined by E sample k is equal to E Tk. If Tk minus 1 is Ts, that means you have here is k, here is a, for example, k minus 1, here is a k. This is the between is Ts. All of the k belong to z, and if t is started by the 0, a sampling stand, then a sample of the k is equal to E kts. How can we model the sample as a system block diagram or the discrete continuous system? If you remember, the problem with the discrete time signal is that we lose some information. If you take the Ts is very small, the sample, the discrete become the continuous. If the sample become big, we lose the information between this sample and this sample, the sample 1, 2, 3. The information between them, we lose the information. How we can express the example signal include some information about the time. If you remember, if signals E attain the continuous time, the take the sample time become E star t. E star t, the sample time of the E t. I can write the E star t is equal to sum of the k start from 0 to infinity of the E kts Dirac t minus kts, or can write the com of the ET. Com will be sum of the minus infinity to infinity of the Dirac t minus kts. This is a very important definition, that the E star becomes sum of the E kts, that means these signals, multiplied by the Dirac kts. I rewrite again, E star t becomes sum of the k 0 to infinity E kts Dirac t minus kts. I want to prove the Laplace transform of the E star t is equal to Z transform of the E s with the Z equal to ESTS. That means Z transform of the E Z here we replace by Z of the ESTS. That means Laplace of the E star s is equal to Z transform of the E when they substitute the Z by the ESTS. Laplace of the E star s will be sum of the k from 0 to infinity E sak E minus k sat. This is the definition about the Laplace in discrete time. Now, in the real sampler, it's easy. You can the EAT with the take the sample become A kts equal to E sample about the signals. In the mathematics, you write the EAT to take the sample. You can write the E star t. If you take the Laplace of here, become E s Here become E star S with the sample. Be careful. E KTS you can rewrite by the E sample about the K is equal to E star T in the mathematical time. The mathematical model is not feasible in the practical or in the practice. The signal is there that is the output of the sample is a continuous time signal. E star T is a continuous approximation of the EKTS. Remember, I write here EKTS is approximately E star T, and or I can write that approximately E S K. This is very important thing you should know. Data holder, now I have the reverse. E star T in digital, I want to find the ET in the continuous time. This is a discrete, which transfer function they go to the analog. Here you have a discrete. I want to find with the holder about the first zero order holder to go to the continuous time. First of all, impulse hold. Normally impulse hold we write E impulse hold will be sum of the E SAK Dirac T minus KTS. You see, this is the Dirac about the sum of the Dirac E SAK Dirac T minus KTS. This will be E star T definition. I want to find the E star T here ET. If I take the Laplace of the output divided by input, I can find the transfer function about the G impulse hold. Here I have a discrete. I want to go to the continuous time. Here become G impulse holder in the S domain become Laplace of the E impulse holder S domain to Laplace of the E star S. This one I know definition becomes sum of this. Exactly become the same as definition about the E star S. These two will be cancelled about, there will be 1. That means J or the transfer function of the impulse holder will be 1. For the zero order holder will be E zero order holder. I will tell you how I wrote this. Become sum of the ESAK step T minus KTS minus step T minus K plus 1 TS. How can I find this one? This is the step holder. A step holder is a combination of the two signal. One signal is a red line, a step about the T minus KTS. Another one is a blue step. If I remove the a step of the T minus KTS minus a step of the T minus K plus 1 TS, this is the blue line. If I remove the red line minus the blue line, I find the green signal. This is the step holder. Okay. Now, Z holder will be sum of the S step T minus KTS minus step T minus K plus 1 TS. If you remember, Laplace of the step will be 1 upon of the S. Laplace of the step t minus ts will be e minus sts divided by s. This is only the revising about to take the Laplace. Okay, now I take the Laplace of this signal. Laplace of these signals will be Laplace of the Ez holder becomes sum of the k equal to 0 to infinity eskts. Laplace of this will be, I can write by e minus kts minus k plus 1 ts minus s is here, divided by s. Okay, I can factorize 1 minus e minus sts sum will be sum of the k 0 to infinity esk e minus skts. I can keep this one. If you remember, e sample of the k e minus skts will be Laplace of the e star s. Exactly, I will find the g transfer function about the 0 order holder. Here will be ET, here will be E star T. That means the output here, Laplace of E0 holder divided by the input, output divided by input. Only I have these signals. This becomes the transfer function about the 0 order holder. Okay, I find the EKTS, that means order E star T 0 order holder become E Z order holder, or in the mathematics I can write E star T E Z OHT. Okay, this is the real of this is the mathematical. If I take the Laplace of here become E star S, here become E Z order holder in the system. Okay, now if you have a ET here, with the sample time I can find the E star T. With the G Z order holder I can find the E Z order holder based on the time. If I take the Laplace, here become E S, E star S, here become E Z order holder. And I find about the what is the transfer function about the GO here. Here become discrete time, another holder become first order holder, second order holder, and the third order holder. That means another function is a first order holder. Here become E star T, here become ET. I want to find the transfer function about the first order holder. Here you can refer to the book and you can find the transfer function about the first order holder, second order holder, and the third order holder, or you can write the first order non-causal, first order delayed, and the first order predictive. The transfer function will be this. This one I will not approve. You can refer to the textbook. In the sum textbook, all these transfer functions are divided by the TS. If you remember, the transfer function about the Z order holder we found is 1 minus E STS divided by S. In the sum reference, divided by TS. This convention is usually used in the digital signal processing in the digital control. It's not in the digital control, used in the signal processing, not in the digital control.